the virtual STEAM Forward Academy. My name is Dr. Janita Pritchett, and I'm the founder of STEAM Forward Academy. Our mission at STEAM Forward Academy is to inspire youth to pursue science, technology, engineering, art, and math with confidence, curiosity, enthusiasm, and a genuine sense of belonging. Our instructors have over 40 years of experience doing education, outreach, and mentoring, and they've combined those passions to make some fun-filled, exciting activities right for you all that you can participate in. We've partnered with First Star National STEAM Academy to bring you guys an exciting activity for today. So with that, I'm going to hand it over to our instructor, Dr. Christina Jones, to take it away. Dr. Jones, take it away.
Hi everyone, I'm Dr. Christina Jones, and today we're going to be doing foaming reactions. And so essentially we're going to be exploring some biochemistry, right, and the impact that biochemistry has on us, but as well as athletes, high performance athletes when we're thinking sports, right? And so when you think about the term biochemistry, you have biology plus chemistry, and so that should give you a hint as to what it means. Biochemistry is just the chemical processes and the chemical compounds that are within and just related to living organisms. Right, and so for us as humans, you hear metabolism, right? Especially when you're thinking about sports, right? So, athletes might have high metabolisms, or you might have a high metabolism. And so metabolism is just this collection of chemical reactions that's taking place that keeps us alive. So that's biochemistry in our body, and part of keeping us alive is food and nutrition, right? So if I'm going to be great at sports, I have to actually really be very nourished. And then when we're thinking of food and nutrition, our food has to be digested properly so that then we are well nourished, right? And so that digestion process is also part of our metabolism. And with digestion, it's just a breakdown of our food. So our body, and this involves many organs like, our nervous system, our brains, our kidneys, our pancreas, our gut, particularly our gut. All of these organs are working together to break down the food that you eat so that our bodies can absorb them, right? And so we want that process, or we need that process to be really efficient if we're going to be playing sports, if we just want to be alive and thriving. It's extremely important. And when we're breaking down food, enzymes play a key role in that, digestive enzymes. And these are proteins that are acting as catalysts in those chemical reactions, right? And so what that means is that it's just speeding up the reactions, speeding up the process. So our digestive enzymes are actually playing that key role in speeding up the way we break down food and the time that it takes for our body to actually get nourished. And so today, we're going to actually be using some reactions, these foaming reactions, to model or to help you better understand digestion in our bodies and just to demonstrate digestion. And so have you seen a chemical reaction? I want you to think about that for a moment. Have you seen a chemical reaction? And if you've seen one, what did you notice? The first thing that came to mind for me was cleaning my bathroom this morning, right? So I'm cleaning my bathroom this morning with these different chemicals. I happened to mix two, and there was this color change and there was some foaming, right? You should never mix household chemicals. Each household chemical has so many different ingredients, so you really need to know what's in it if you're gonna mix them. But what I was witnessing was a chemical reaction. And so it's important to note the difference between chemical changes and physical changes, right? So when you have a physical change, nothing new is formed, and it's often reversible. So think about ice melting. Ice melts into water, but we can freeze that again, and it becomes ice, right? And so it's still water, nothing's changing, and that process was reversible. But for chemical changes, something new has to be formed, and it's irreversible, right? And so things that you'll notice are color changes. And so when I was cleaning the bathroom and that foaming happened, the color changed. It went from white to pink. There's odor changes as well as temperature changes. And so again, today we're going to be exploring chemical changes. What we're really going to be looking at is the breakdown of hydrogen peroxide. Hydrogen peroxide is a typical household chemical. You use hydrogen peroxide, or you're probably very familiar with it from maybe like cleaning wounds. It's an antiseptic. But what we're going to be using it for today, again, is to demonstrate biochemistry, chemical reactions in our body. And so hydrogen peroxide can actually break down into water and oxygen, right? Like the two vital things we need to actually live and thrive as living organisms. But the challenge is that that breakdown occurs slowly. Similarly to digestion if we don't have enzymes. And so what we're going to have to do is actually use a catalyst like digestive enzymes to speed up that breakdown of hydrogen peroxide. Today, yeast will be that catalyst. And so that's what we'll use as we conduct our experiments, again, to help you understand chemical reactions in the body, particularly enzymatic reactions, and model that digestive process. So in order for us to do these foaming reactions, we're going to need a few things, and I want to go over that first before we actually start our reactions. Okay, so I mentioned that today the reaction that we're using to try to understand digestion a little bit better is the breakdown of hydrogen peroxide. So if we're breaking hydrogen peroxide down, we definitely need it. So you have your hydrogen peroxide. We're going to need some liquid soap, and then we're going to need our catalyst. And you likely remember that I mentioned that yeast would be our catalyst today, so have to have the catalyst. We have some spoons that we can measure with. We're going to want to make sure that we're measuring accurately as we do our reactions. Room temperature water, so this water has been sitting here for probably 15 minutes. That's more than enough time for it to stabilize, the temperature to adjust. We have a graduated cylinder that we're going to use to actually measure out our water, cups for our reaction, and then the output of our reaction, what we're going to be measuring is the height of foam. So that's why we're terming the activity foaming experiments. And so we have a ruler so that we can actually measure that foam that's going to be produced. We have a thermometer so that we can take the temperature of our reactions before and after. And then scissors, if needed, to actually get to the yeast and tear those packages. And then, whenever we're working in the lab, particularly, it is just so much more important sometimes when we're working with chemicals and doing biochemistry. We want to make sure that we are protected. And so I have some safety glasses here that I'll throw on. I already have my lab coat on. My hair is actually pulled up as well so that it doesn't interfere with anything that I'm going to do. And then gloves. And that completes my PPE. Or personal protective equipment. And so, once I'm suited and booted, we can actually start having some fun. So I'm suited and booted, you know what that means. Time to start getting these reactions going. And so I'm just going to set my supplies to the side so that it gives me more space to work in front of me and you can really see what I'm doing. Another important thing, I want to use this aluminum foil pan to contain my workspace or the reactions, right? Because I want to make sure that I'm as neat as I can be. And if not, the table is covered, and so I'll be able to clean up anything that I need to. I didn't mention it when I was going over the supplies, but we're going to be recording some data, and so it'll actually be really, really good if you also have a sheet of paper and a pen, so that you can make a table similar to mine that I'll get into. All right, so this is cleared, it's ready for me. And I'm going to keep saying it. So, we're modeling digestion, and what speeds that process up are those digestive enzymes, right? Those enzymes serve as a catalyst, and we're going to be mimicking that using yeast. So the table that we're going to use to record our data, there's a few things we're going to be capturing in it, right? So we're going to do 3 reactions. And for each reaction, we're going to have hydrogen peroxide in it. That's what we're breaking down. We will be using the dish soap. What's important about the liquid soap is that as hydrogen peroxide is breaking down, remember I said that it produces water and oxygen. Well, the liquid soap is gonna trap that oxygen as it's being produced. That's gonna create our foam, and so that's what we're measuring. So that's why this is so important for us to capture the height of that foam, but then we're also gonna be recording the temperature. So before we start our experiment and once we're done. So we're recording those 3 data points for our three different experiments that we're gonna do. So since I know that it's gonna be three experiments, 3 reactions, I'm just gonna grab 3 cups for those reactions to take place in, and I'm just gonna I'm grabbing a marker so that I can label them 1, 2, and 3 and be able to tell what my different reactions are. All right, squeaking a little bit. Okay. So, what we're gonna need again for these three reactions are a catalyst, which is the yeast. So I'm just gonna make a catalyst solution that we'll add to our reactions. And I'm gonna label that cup C, C for catalyst. C is also the first letter of my first name. So I like it. Okay, I need to measure out 100 milliliters of water to actually make this catalyst solution. And so I'm gonna also do that in this container. All right, and so what's important here as I'm pouring the water to measure it in the graduated cylinder, I'm just gonna make sure I'm actually holding the base of the cylinder so that it doesn't move and it stays stable as I'm pouring out this water. And so when you're measuring liquids in a graduated cylinder, you have what's known as a meniscus, and it's just kind of a curve that forms at the top of the liquid. And so you always want to actually look for the bottom of the meniscus to touch the number you want the bottom of the meniscus to be at the volume that you're measuring for that liquid. And so for me, I see that the bottom of my meniscus is right at the 100 milliliter line. So I actually don't even need that water anymore. I'm gonna pour this into the cup that's gonna have the catalyst solution, my C cup. And then the next thing I'm gonna do, and what you wanna do to finish making this solution, is to actually add yeast to it. And so I have a double packet here. We only need 1 packet. So I'm just gonna cut it. You can do the same if your yeast looks like mine. And so in this 100 milliliters of water that I just measured out, I'm gonna I will pour all of the yeast in this packet into it. So go ahead and open your packets up. Pour your yeast into the water. Mine is just sitting on top. It almost looks like sand. Okay, just putting that to the side. And then just grab one of your spoons and stir that catalyst solution up. So we're gonna keep stirring. We want our yeast to actually fully dissolve in the water. Right now for mine, it seems like it's clumping up just a little bit, but it's not sitting at the top like it was when I first poured it in. The solution's a tan color. It almost reminds me of almond milk. And just keep stirring. Got some bubbles forming as I'm stirring. I'm seeing more of the yeast dissolve, so I'm seeing less of it, which is how I know that more of it has dissolved. And I'm just gonna keep stirring. Another thing you can do is just kind of lift a little bit up. You lift a spoonful of it up. And that way that'll help you see if there's anything left that needs to be dissolved. Oh man, and I'm just still stirring. We're almost getting there. And as you stir, just make sure that you're not having any of the yeast spill out or the solution spill out. That means you're stirring too vigorously, so you just want to slow it down a little. It's important that we actually have that full packet in the 100 milliliters of water. And so I'm almost there. Almost. I'll just go a little bit longer. Okay. I think I'm there. Yes. All right, so as I'm just scooping up a little bit of the solution, I don't see any solid particulates anymore. So I'm pretty certain that all of the yeast has dissolved. And now I have my catalyst solution, and hopefully you have yours as well. Okay, so I'm gonna keep the spoon in here. It's gonna actually need to measure out the catalyst solution to put into our reaction cups. And you notice I was almost about to sit it on the table, but I'm gonna keep it in this container to make sure it's contained if a spill were to happen. Okay, so for the reactions, what's going to be changing is the amount of hydrogen peroxide that's added. So we're going to have the same amount of the catalyst solution. We'll have the same amount of liquid soap in each of these, but we're going to change how much hydrogen peroxide we're putting in. And so we're going to increase the amount as we go. So the next thing that I'll do, and what you can do, is we can actually put our liquid soap in each reaction. So we're going to measure out a half teaspoon of liquid soap and put one in each of your reaction cups. And so if you don't have an actual teaspoon measuring cup, you can just use a plastic spoon, and you only want to measure out a half of one of these spoons. For your liquid soap. And just try to get it in the center of the cup so that most of it is down at the bottom and not on the sides. It's okay if you get it on the sides, but we're gonna try to make sure to just have the reaction happen in the center of each cup. So I put a half teaspoon in my first reaction cup. Now I'm putting the same in my second reaction cup. And guess what? I'm gonna do it for a third time as well, for the third reaction. We got a little bit on the sides in that one. All right, and so at home, if you have any paper towels or something like that, you can put the spoon on those just so that you don't get soap everywhere. I'm just gonna stick it right here in this container, and it'll be out of the way. And as I mentioned before, the amount of soap and the amount of catalyst is gonna be the same in all three. What's changing is that amount of hydrogen peroxide. So as they're numbered, that's how many teaspoons of hydrogen peroxide we're going to be adding in. And that's the first column that's actually in the data table that we're going to be using to collect our results. And so what I'm just going to record here is that in reaction cup one teaspoon or spoonful of the hydrogen peroxide will be added. For reaction 2 teaspoons will be added, and then for reaction 3, we're going to add 3 teaspoons. So I'm just writing that now. So that even though it's not too difficult to remember, it's captured there, and that's just a good practice. You always want to write down your results, any data that you think is important, and observations as well. And so now that we know how much we're going to add, to go ahead and do that. I have a brand new bottle of hydrogen peroxide here, so I just need to take a moment to open it up. All right, I'm back in business. All right, so reaction number 1. Do you remember how many spoonfuls of hydrogen peroxide I'm gonna add? Any guesses? Just 1. All right, and if you notice there, it was actually not too easy to squirt this onto the spoon, and so I'm holding my spoon over the cup as I measure this, just to try to contain anything. All right, so there's my first spoonful. Or I didn't mean over the cup as I measure this, over this container as I measure it, so that it can hold anything. All right, so there's my 2 spoonfuls there. I'm just gonna move the catalyst over here. So we don't want anything getting into that solution. And so for reaction number 3, I have 3 spoonfuls of hydrogen peroxide, which is what we're going to be breaking down when we add our catalyst in. All right. Okay, now that we've finished adding our hydrogen peroxide, we can actually start our reactions, right? And so what's missing to start those reactions is that catalyst solution. So I had said before, we're gonna measure the amount of oxygen that's produced by measuring the foam that's gonna occur, foaming reactions. But we're also gonna measure the temperature, right? And so when chemical changes occur, they can be endothermic or exothermic. And so an endothermic chemical reaction, it just means that as the chemical reaction is taking place, heat is absorbed from the environment, and so that reaction becomes colder than it was when it initially started. And so when they're exothermic, when these chemical changes are exothermic, that means that heat is being released, and so they're warmer than they were, or that the reaction is warmer than it was when it started. And so we're going to measure our starting temperatures and our ending temperatures to also be able to just learn a little bit more about the breakdown of hydrogen peroxide that we're doing catalyzed by this yeast. So since we're about to start, I'm just going to go ahead and put the thermometer into our first reaction cup and give it a little time, a few seconds to stabilize, for the temperature to stabilize, before I add the catalyst in, our yeast, to start the reaction. We'll let the reaction go for 2 minutes. And then at the end of that 2 minutes, we'll get that temperature, do a temperature check again. But then the important part, I guess it's all important, is to actually, we're gonna measure the height of the foam that's produced by the reaction. All right, so I think we're good here. So my before temperature for reaction 1 is 25 degrees Celsius. All right, and the amount of catalyst solution that we'll be adding to each cup is 1 teaspoon. So I'm just going to stir it a little bit to make sure it's homogeneous before I put it into the reaction. All right, so because I'm trying to hold the thermometer, I don't want the cup to tip over. Let's see, I'm gonna just put my spoon in to get the spoonful. All right, It's time for this first reaction to start. Ooh, so after you add your catalyst in, you want to use your thermometer to mix up the solution. And the second you added your catalyst in, you should have started your 2-minute timer. And so what's happening here, as I mentioned before, again, the hydrogen peroxide, it's breaking down into oxygen and water. And that liquid soap that we added into the reaction cups, it's capturing that oxygen, and so we get in the foam. The foam is forming as a result of that. And so I've stirred it enough. We'll just let our 2 minutes pass and see how much foam we get. Right now it's about half of the cup. I don't really see it moving much. It could be that the reaction is complete. Once all of the hydrogen peroxide has broken down, then there's nothing left for our catalyst to work on, and so then our reaction would be complete. Which means it finished in under 2 minutes. The temperature's increasing. I think I'm at about 34 degrees Celsius right now. We'll see what it is at the end of those 2 minutes, or at the end of our 2 minutes. Okay, so that's 2 minutes. We're done timing our first reaction. My temperature right now, it's still 34 degrees. So it's 34 degrees Celsius. So that was a 9-degree increase, which means that the reaction is exothermic. And I'm just gonna bring this out of here so that you can see. So I'm gonna measure the height of the foam in centimeters. And I'm putting my 0 mark. So let me hold the cup steady here. I have a very small amount of liquid soap, and so I'm just starting my 0 right where the foam starts. And so for me, it's about 4 centimeters. So I'm gonna record that. So at the end of the 2 minutes for our first reaction, I measured 4 centimeters. 4 centimeters of height for the foam, 4 centimeters of foam that was produced. I'm wondering what you are seeing. Okay, and so, all right, so now we're gonna start our second reaction. And once again, we're gonna measure that before temperature. So I'm just gonna put the thermometer here for several seconds. Make sure that it stabilizes, it gets the correct temperature. Right now it's 25 degrees Celsius again, like our first reaction. See, and I'm just gonna hold the cup here so I don't make any accidents. Okay, and we're still at 25 degrees Celsius, so I'm just gonna record that in my table. It's the same as before, so it's consistent. Okay, and we're gonna start this reaction. And so what we want to do is add a spoonful of the catalyst. Stirring it a little, make sure it's homogeneous. All right, and so I'm adding it in. I'm gonna stir to make sure it's mixed, and that started our 2 minutes. Remember, we're letting the reaction go for 2 minutes. We're going to record that after temperature, as well as the height of the foam. And so I'm just stirring it to mix it a little bit. I'm just going to leave it here now. Right away, I can see that the height of this foam is more than 3 centimeters. I'm sorry, 4 centimeters is what the first one was. I mean, it might actually overtake the cup or come up out of the cup before our 2 minutes is up. And so again, what's happening here is that hydrogen peroxide is breaking down, right? Our yeast in this catalyst solution is breaking down all of the hydrogen peroxide. So we added double the amount of hydrogen peroxide in this reaction compared to the first one. And we have a lot more foam. So that means that the same amount of catalyst can actually break down more hydrogen peroxide than we put in our first solution. Again, we're modeling kind of what happens as our digestion or our digestive system processes our food. And again, those digestive enzymes, typically proteins, they're, speeding that reaction up. So, food hits after we eat, it hits our stomach, and then it goes into our small intestines. And that process takes about 4 to 6 hours. And that's where most digestion happens. So I don't even know how long it would take if those enzymes weren't doing what they, were doing so that we can absorb nutrients. 4 to 6 hours is already a long time. So with the enzymes, that means that's the fast reaction. It could take a few days without those enzymes. All right, you heard it. That was our 2-minute timer. I am at, that's 37 degrees. So it's warmer than our first reaction. And I'm gonna grab my ruler. And again, we're measuring this height in centimeters. I'm just gonna put it here just for visualization. And again, I'm putting the bottom of the ruler right where my foam started. I still have some liquid soap in the cup. Man. So my foam, I'm measuring 7 centimeters. Wow, so not quite double the first reaction, which was 4 centimeters, but still a lot more. All right. So we have 1 reaction to go. And to think, if the foam for this reaction came all the way up to the top, what do you think is going to happen with reaction number 3? All right, so just cleaning my thermometer. Let's get our before temperature measurement. And I'm expecting the temperature, that before temperature, to be the same as it was for reactions 1 and 2. Let's see. Again, reaction 2 was warmer. So evidence once again that this is an exothermic reaction. Okay, so this is measuring 26 degrees Celsius, still consistent with our other before temperatures. All right, I'm ready to start the last reaction. I'm just gonna move this over a little bit. And again, if you have another container or something that you can have your cups in, you wanna make sure you're using it. I have a feeling that this foam might get a little crazy. So, stirring up my catalyst solution again. Why? I want it to be homogeneous. Just need 1 spoonful. I want to make sure I get a spoonful like I did for the other 2. Okay, time to start our timer. And again, I'm just going to stir it some in the beginning to make sure that the catalyst is mixed in. Be careful when you do this. You don't want to knock anything over, so I'm just going to hold the cup. just gonna keep it here. I must say, I was expecting a little more for this one. Let's see. It's still rising though. It may not disappoint me. Okay, it's rising higher. It just might fall over the top. And you could probably see on your timers how much time we have left. I can't, so I'm just sitting here like, oh, is it 10 seconds? Is it 30 seconds? And it's still slowly rising. And I'm just holding the thermometer so that the cup doesn't topple over. It almost looks like a sundae without the whipped cream. Okay, there's our soft timer. All right, so what's the temperature? Okay, I'm getting 37 degrees again, 37 degrees Celsius. That is my after temperature. So it was an 11-degree temperature increase. And I can see that more foam was produced, but I thought that it would have been about triple this, which doesn't seem to be the case for me. I'm measuring in centimeters, I was looking at inches there. And so to the top of the cup, it's about 8.5 centimeters. It's a little above the top, so it's definitely more than that, but I'm just gonna record 8.5 because that's all that I can measure. And so that's 1.5 centimeters, 1.5 centimeters more than reaction number 2. And so what likely happened here was that the catalyst can only break down so many of the hydrogen peroxide molecules, right? And we use the same amount of catalyst in our we use the same amount of catalyst in our 3 reactions. And so what happens is that at a certain point, we would need to add more catalyst to be able to break down all of the hydrogen peroxide that's in the reaction. And so for our reaction number 3, that didn't quite happen. We needed more catalyst so that we can actually see, we needed more catalyst so that we could have produced more foam and broken down all of the hydrogen peroxide that was in the reaction. I'm just gonna wipe it off here so I can actually get this out of my hand. All right, and so that's something you can actually do. You can do a 4th experiment or 4th reaction or even a 5th reaction where you're changing the amount of hydrogen peroxide you're adding in, or you can change the amount of catalyst that you add in and then just see what happens as you change those variables. You know, are you producing more? Are you getting a higher or taller foam column? You know, just different things to note and observe, you know, make a new data table. And those observations can really help you even understand more about how catalyst works in reactions. I hope that you had fun and really enjoyed the reactions. And so we always like to end our activities, our demos, and anything that we do by saying steam forward. And so on a count of 3, I want you to scream steam forward with me at the top of your lungs. 1, 2, 3. Steam forward! All right. Thank you for joining me today. I'll see you next time.